Hey guys, so today we're going to talk about scatter plots, lines of best fit, and the correlation coefficient. So let's get started. A scatter plot is a graph that shows the relationship between two quantitative variables. The explanatory variable is a predictor variable. It's plotted to the horizontal or the x-axis. It's the independent variable. The response variable is a value explained by the explanatory variable. It's plotted on your y-axis, and it's the dependent variable. Why might we need to see a scatter plot? So if you study statistics or you're a quality control technician, you might use them to gather data to determine correlations between two events, and a correlation is just a relationship. You can kind of look at them pretty quickly and see if there is a relationship between two sets of data. And they're super easy to predict values based off of your graph using a scatter plot. So correlation, like I said, is the relationship between two variables that you're measuring. If there's a strong positive correlation, that means your values go up from left to right, and they're pretty close to being in a straight line or having a linear relationship. If there is a weak positive correlation, that means your values still go up for the most part, but they're not quite as close to that perfect straight line relationship. And then the same is true for negative. The only difference is your values go down from left to right instead of up. So a strong negative means they go down and they're pretty close to being that straight line. And weak means that they go down, but they're not quite as linear as the others. And then no correlation means that there's probably not a relationship at all between your two variables. So some examples of each one: there's a strong positive, it's going up, and then they're pretty close together. There's a weak positive, they are going up, but your dots are a little bit more spread out. There's a strong negative, a weak negative, and then no correlation means they're not related. Your dots are pretty much scattered over the entire graph. Okay, so let's actually make a scatter plot. So I have some examples of some different sandwiches here and how many fat grams that they have per sandwich. And then we're going to compare that to the total number of calories per sandwich. So let me swap over to Desmos. And when you get in Desmos to add a table, you click Add Item. And we're going to add a table. So our fat grams are going to be the X values. So let me add those real quick. Then our Y values are going to be the number of calories. It should be 320 instead of 324. And then I'm going to click on the toolbar over here, and I'm going to change the parameters for my X and my Y axis. That's our numbers are a little bit bigger. The fat grams start at 5 and they go up to 34. So I'm going to go up to 40. And our y values go up to close to 600. I'm going to stop it at 600. Okay. So that's how you make a scatter plot using Desmos. I would say this is a positive correlation. It's pretty strong. Your dots are pretty close together. So we could even say it's probably a strong positive. What that means is as our fat grams get bigger, so as our X values increase, our calories or our Y values are also increasing. All right, let's go back to our slideshow. Whoops. So with scatter plots, we have something called the correlation coefficient. And that is the measure of the strength of your linear relationship. And they use the letter R to represent the correlation coefficient. Your values are always between -1 and +1. Obviously, if you have a positive number, that means you have some sort of positive relationship. If you have a negative number, then you're going to have a negative relationship. If your R is equal to +1 or -1, then it's a perfect linear relationship. All of your points will lie on a straight line. The closer it is to positive or -1, the stronger your relationship is. And if it's close to 0, that means it's weaker or there may not be a relationship at all. And all correlation coefficients will always be between -1 and +1. Another aspect to scatter plots is called the line of best fit, and it is used to predict data. And so what you do is draw a line through the center of most of your data points. Your line should pass through as many of your points as possible. And if you have to put it not on every point, you want some of your points above it and some below it, preferably equal numbers above and below. So let's look at this example. As your age increases, if you have a bachelor's degree, I want to see if your salary will also increase or decrease, being positive or negative. So I'm going to swap back to Desmos again. And I'm going to delete this table that we've got, add a new one. So our age is going to be our X values. And the salary amount is going to be the Y values. Okay, I'm going to go change my settings to match my numbers a little bit better. Our highest salary looks like it's 85, so I'm going to bring this down a good bit. Let's go to 90. Okay, so there's our scatter plot. Once again, it's also a positive correlation. Our points are going in the upward direction from left to right. So to get the correlation coefficient and the line of best fit, we can also do that on Desmos. So I'm going to open up my keyboard. Now to get the line of best fit, remember from when we did linear functions, our formula for a linear function is y equals mx plus b. M is your slope, b is your y-intercept. So we're going to use that same thought process and put that as our formula for the line in Desmos. The only difference is when we type our X and our Y, we're going to add the little subscripts like they have here and here. That way it uses this data from this table to make our line of best fit. So I'm going to start with Y. The subscript button is this right here. Instead of the equal sign, we're going to put this little symbol. And the slope is M, X. Use the subscript again and put X1. And then plus B for our y-intercept. I'm going to close my keyboard. So you can see the line of best fit was drawn for us. It goes through the center of our data points. We've got some points above the line. We've got some points below the line. And if you'll look over here, it will actually tell us the equation for our line. So this M right here would be our slope, which should be close to 1.56. And the B value right here would be your y-intercept. So if we were going to write an equation, it would be y equals 1.56 if you rounded X minus 4.26 if we rounded that also. Okay. And so what you do with the line of best fit is you can plug X values into your equation for X right here and multiply it times the slope and then add the y-intercept, and it will predict what your y value should be. So if we put 40 in for our X value and work that out, it would actually give us 58.105, okay? And then if you look back over here, the correlation coefficient is this R value right here. And it says 0.8795, which indicates a pretty strong positive relationship. That's pretty close to +1. And you can see that by looking at the graph here. All of our points are pretty close to this straight line. There's a few that are kind of spread out, but for the most part, it's a pretty strong positive relationship. All right, I'm going to swap back to our slideshow. I think there's another example. So on this example, I've got some famous movies and their cost and then what they grossed after they came out. Okay, so our cost here is going to be the x-axis numbers, and the gross is going to be the y values for our equation. So let me swap back to Desmos one more time. Now I'm just going to edit this table that we have here. So the line will probably do some crazy things while I'm typing these numbers in. Don't let that confuse you. Okay, then I'm also going to change my settings to match our numbers. Okay. So we can look right here. This is also a positive relationship. It's not quite as strong, I don't think. I haven't looked at our correlation coefficient yet, but just by looking at it, you can see the dots are a lot more spread out than they were earlier. So I left our formula in here for the line of best fit. And so it calculated that for us. This time our slope is about 3, and our y-intercept is close to negative 208. So once again, we could pick an x value right through here and plug that in for x, and it would actually predict the y value based on our line of best fit. And then our correlation coefficient is 0.52, which is pretty weak. Okay, that's getting on closer a little bit to 0. So we can tell by looking at that. If it just gave us the correlation coefficient, we could tell that that's a weak relationship right there, because that's not close to positive or negative 1. Okay. All right, well, that's all I have about scatter plots, the line of best fit, and the correlation coefficient. Have a great day.